So my name is Kevin Ward. I think looking at the people on the call, I've met some of you. Haven't met everybody though. But for those that don't know me, my role here at Petrosys is as the support manager, and I'm a sales geoscientist as well. So my background's in geology and petroleum geology, and I've been using Petrosys PRO for almost a decade now. So got quite familiar with the software, and hopefully what I'll be able to do today is show you some of the features that you may have missed, either some old features or some new features. So the title of the webinar is Advanced Subsurface Mapping in Petrosys PRO, and I was asked to put together this demo for the EAGE conference in London. And what I thought I would do is just try to pick 4 or 5 kind of key features of Petrosys PRO that geoscientists use to help with their subsurface mapping. And the workflow today is particularly focused on exploration mapping, but of course it can be used in a production environment as well. So what I'm going to do then, I've got a very short PowerPoint, and then I'll go into a live demonstration of the software, and it should take about 20 minutes overall to get through the whole webinar. Everybody's on mute at the moment, but you'll be able to ask questions at the end. You can type into the chat log, and the video will always also be available on the website afterwards. So if you are watching this as a video, then please do get in touch with us, perhaps through support, and we can answer any more questions. So the workflow I'm going to do today then has 5 parts to it. The first is just to show how easy it is to actually display your subsurface data from other applications onto the Petrosys PRO mapping canvas. And once we've displayed the subsurface data, we're going to then look at how we can use the gridding algorithms within Petrosys PRO to generate a more realistic surface by including faults at a very early stage in the gridding process. Once we have a surface, we can then edit that surface, and I'll introduce you to the Spatial Editor. Now the Spatial Editor has been around for a little while. I guess a lot of people will be familiar with it, but we do find that there are quite a lot of good users who are still not got to grips with the Spatial Editor. So I'll introduce that tool, and if you want more help in that, you can let us know, and we can go more in depth into that. We'll then look at how we can identify prospects with our improved surface. And this is a tool called the Lowest Closing Contours option. It's fairly new to Petrosys PRO, and so some people may have missed this, and we thought we would just show this to show how we can identify prospects across the surface. And then finally we'll look at how we can calculate volumes. And the volumetrics option has been in Petrosys PRO for a while, but it's also always good just to recap on how that works, and also introduce you to the probabilistic volumetrics that Petrosys PRO now has. So those are the 5 topics I'm going to focus on, and I'm just going to now jump straight to the software and start with the first one, which is all about how easy it is to display data. So let me jump out of the PowerPoint, and I'll go into Petrel. So all of the data I'm using today is in Petrel, but remember that Petrosys PRO tries to be a vendor neutral application. So whether you're using Petrel or Decision Space or Kingdom or Paradigm or Dug Insight, whatever it may be, the data is used directly within Petrosys PRO. We don't need to convert it in order to use it. We can just use it directly from its source. And you'll see that the data I have here, I have some 3D interpretation, and I also have some fault sticks. And I'm going to assume that I want to try to do some subsurface mapping, some exploration work using this raw interpretation data. And I'm going to use Petrosys PRO to help me do that. So I'll click on the Petrosys PRO icon, and the first thing you'll see is that I don't actually have a project available at the moment. And so Petrosys is going to automatically generate the project for me. And the reason for doing this is I didn't want to use a project I'd already created with lots of things already set up. I wanted to show you how easy it is to use a brand new project and just get started very quickly in the latest version. So I'll make Petrel a little bit smaller, and I'm going to jump straight into the mapping module within Petrosys PRO. Now obviously this is much easier on Joe screens. I'm using a laptop here, but I'll move this over, and I'm going to just get some data onto the map then to start looking at it. So the first thing I'm going to get on is some interpretation. So I've got my 2 time interpretation here. And I'm just going to simply click on that and just drag that onto the map. And you can see that displays straight away. So the integration then between applications is very easy. So for displaying subsurface data, it's very easy to get the high quality canvas of Pro using your subsurface data. So I've displayed some interpretation. I'm also just going to get a surface on here as well. I think it's further down this list. And it's in this one here. I'll take the top tarbet and just drop it on there. Great, so very quickly, I've got some data on my map. Now, in terms of making the high quality maps that people expect from Pro, it's now very easy in the latest version because of the style templates and extent templates and also base map templates as well. So this is something, if you haven't used the software in a couple of years, you would want to try to get familiar with. It makes the software much more easy to replicate maps in different parts of the world or at different scales or different extents. So I'm going to click this icon just to lock in the extent here, and I'll toggle off the interpretation. I'll just leave myself with the surface, and I'm just going to select a different style so that the map looks a little bit nicer. So rather than using the basic style, I'm going to jump to the PowerPoint style, but it could be any of other styles that I've created. It could be any other corporate templates that my company wants me to use. So it's very easy to take the data, stick on a high quality template, and then you've got a map that's ready for presentation. Now if I look a little bit more at this surface that I've got, we've got the usual options within Pro to improve the display. So I can click on this here. At the moment it's picked up my Petrel gradient, but I might want to use something a bit nicer. So let's try the pastel colour one to display that on Pro. And we can also toggle on faults and contours from within this panel now. So this was something we did reasonably recently, so you may have missed this if you haven't used the software in a little while. It used to be that you used to have to display grids, faults and contours all as separate layers, which made the workflow a little bit more cumbersome. Now we include everything within the one panel, which means all of these objects relate to each other. Now in this workflow, as you saw within Petrel, I don't actually have fault polygons available. I've only got the fault sticks, so I'm going to leave that turned off for the moment. But I do want to toggle on contours, so these are generated on the fly for me. So I will display every 20th contour, and every 100 I'll just make a little bit thicker. It's automatically picked up that this is in time. I'm going to just toggle off the milliseconds label. I could stick on some contact values if I have single contours. I'll leave those off, and I'll display it like this. So this is the surface that's come from Petrel. Now with Petrel and with some other interpretation systems, one of the problems is in the exploration part of the workflow, or also in production sometimes, you've not generated a full geological model. And the problem with that is that you're then not able to have fault polygons within the surface. So with Petrel, you have to really generate a full model before you can start to include the fault polygons within the surface. And you can see here, this is the sort of typical thing you get with interpretation systems, where it simply contours straight through that large change in slope where the fault is. And the problem with that is that for volumetrics and for other model building activities, the contours are not quite geologically accurate because they simply contour straight through that change in relief. And so the next step of our workflow then, if I go back here, will be to actually generate a grid of the data using Petrosys PRO. So what I'm going to do then is I'm going to come out of mapping and I'm going to go into surface modelling. And within surface modelling, this is where we can generate high quality surfaces that we need. So I'm going to go to the create grid option, but note there are a lot of other options in here for grid processing and gridding operations. I'm going to just type a name for the output grid, so I'll just call this the top tarbet. It's in 2 time. And again, you'll notice now throughout the software there are blue arrows. If you're using Petrel or Decision Space, there are these blue arrows which just make it much easier to use the software. So I can go back to Petrel, I can click on my interpretation, and now I can simply click on the blue arrow to populate that in the panel there. I'm also just going to use the outline of the 3D survey to set the origin and the extent of my grid, and also the cell size and the rotation angle. So that all comes from that 3D survey. Under the methods, you'll find that there are a range of more advanced methods, such as kriging and kriging with external drift. There are a range of gridding algorithms. And again, these are all things that I could have included in the webinar or in the demo, but I wanted to keep it fairly short. So just be aware there are more advanced gridding operations and algorithms available. And if you're on LinkedIn, you'll also find we did a couple of articles recently to explain a couple of these algorithms. And we also did one to explain the cross-validation method as well. So if you're on LinkedIn and you're reading some of our articles, you'll find a little bit more information about those. I'm going to stick with the standard gridding method, but I do want to include faults. So I'm going to use fault data. It's fault sticks that I have access to rather than fault polygons. And I'm going to go back to Petrel, click on my fault sticks folder, and I'm just going to simply drop those in there. And you can see it's picked up the 22 fault sticks within that folder. I'll stick on a little bit of smoothing. I'll save the fault polygons as a separate file, but I don't really need to do that anymore. And I'll grid within the faults. Click OK, and that's now been generated. So you can see that the value here is that it's very easy to use Petrosys PRO's advanced subsurface mapping algorithms and operations with your interpretation data. And the other value I'm showing here is that we're using the fault stick gridding operation. So if you have not generated fault polygons within Petrel, for example, you can generate those nice and easily in Pro by allowing the software to combine the interpretation picks with the fault sticks. And if I go back to the mapping canvas, I'll just display the result to show you what it's come up with. So this was the grid. Got the colour fill grid, got the contours on. Let me just stick in those values again, so 20 and 100. And this time we now have faults, so I can toggle those faults on, and those are displayed. I'm going to give them a solid fill style, but remember we did contour within them, but I'll give them a solid fill style, and I'll just toggle on the symbols. And there we go. So we've got the grid now, and we've got the faults embedded within the grid file, and you can see the contours come up nicely to the edge of those faults, and they snap on nicely to the edge there, giving the more geologically realistic surface with the way it interacts with the fault polygon itself. Okay, next step then. I've generated the grid. The next thing I want to do is edit the surface to make it a bit more accurate. And to do this, I use the Spatial Editor. Now in previous versions, the Spatial Editor only allowed you to edit contours and faults. In the newer versions, it can now edit grid surfaces as well. So if I click on the grid and click on Edit, it will launch the Spatial Editor. The tool itself is really powerful. It's one of these tools that, because there's so much in here, it can sometimes take a little bit to get used to. But there are a lot of really good features within this tool here. To edit surfaces and improve those surfaces. So once you get used to the way the icons work and the way these buttons work, it really is a very powerful tool. So give this a go if you've not got to grips with it. Let me know, let us know at support, and we can try to do a little bit more tuition with you to show you where the power of this tool is. I'm going to switch to the contours mode, which gives me some different options, and you'll see it split into edited data as well as generated data. Now, because I'm going to make edits to the surface, I want to toggle on the interpretation. I want to make sure that what I'm doing is valid rather than just simply making stuff up. And I'm going to toggle off the colour fill grid here, and I'm going to zoom in to this area. I will toggle on the faults, and I'm going to make the faults a little bit thicker, just so I can see them a bit easier. And I'll also just give them a solid fill style again, just so we can see those a bit easier on the screen. So there's the faults there. Now there's lots of places in this surface that I could edit, because the actual fault stick interpretation is not as reliable as it could be. But I'm going to focus on this little area here, where the fault polygon that's been generated is not quite accurate. And again, it's just due to the poor fault sticks. And there are a range of things I could do with the editor. So for example, I could use the smoothing tool just to come in and smooth that fault polygon a little bit. If that's not enough, perhaps I could take the fault polygon and I could remove a section. And looking at the gaps in the interpretation there, I could come back and just simply digitize the fault polygon back in. I could combine it with this fault polygon if I wanted. So what I want to do is up to myself. There's a lot of degrees of freedom as to what I do there. But the real power of this tool is that once I've made those changes, I can then sync those changes back into the surface, whereas previously you had to go back into surface modelling and you had to regenerate everything manually. I can now do it all within this one tool here. So if I click on the edited contours, there's no point in me just regenerating this surface using these existing contours. I may as well remove some of the contours to give the algorithms a bit of freedom when it's regenerating the surface, because now everything in this area has changed. So I'll remove these contours here. And what I'll do now is I'll click on this icon here, which does a localized regrid. And I'll just change the buffer. And you'll see that it's only going to make changes in this area here where I've actually made those changes to the contours and to the faults. And this is very powerful. What you'll find in interpretation systems is that it will regenerate the entire surface from the contours. And the problem with that is you lose a lot of detail between the contours, a lot of information between that contour interval is then lost. What we're doing here is we're simply editing this localized area. We're not making changes over in this area. We're not making changes over here. We're simply editing within the localized regridding area. And you can increase the cell refinement if you need something more accurate. You'll see it reduces the size of the subcells, so it can take a little bit longer, but you get a more accurate result. I am just going to leave that set to 2. I will click OK, and it will regenerate the surface. I'll click Save, and I'll close down the editor now. And I'll look at my changes when they appear. We've regenerated the surface. There we go. I've got the contours in there. If I'm still not happy with them, obviously I can go back and make further changes, but I'm fairly happy that that now looks a bit more accurate. And as I said, you might decide you want to combine these faults so you have a nice trap there. That's entirely up to yourself as an interpreter as to what you do. The point is though, I've now got a surface that I'm happy with, so I'm now going to go ahead and identify some prospects in this surface. So to identify prospects, we'll use a tool called the Lowest Closing Contours option. It's a fairly new tool. It's very powerful. There's a lot of things you can do to it. You can start at a very basic level, or you can start to include things like dry holes. You can start to include whether faults are sealing or leaking. You can include clipping polygons. You can do a lot of things to identify prospects across the surface. The tool itself then is in surface modelling. And if I go back to my workflow, under contours, it's called Lowest Closing Contours. And you'll see within here there are all the features I talked about, the faults, the clipping polygons. You can include whether you want only larger closures. You can include whether you only want closures at contour intervals to increase the performance. What I'm going to do is simply stick in my grid, which is called Top Tarbit. Note that you can also use grids in other software packages as well. I'm going to invert the scaling, and I'm just going to say that all of my faults are sealing faults for the purposes of this demo. I'm not going to bother with any dry hole data or oil-water contact data. And I'm going to just type in a name for the output, which comes as a shapefile, so I'll call it closures. Click OK, and that will run. So it's now using the faults, using the contours to identify all of the closures across this grid. So the value here is it's a very powerful tool to find prospects, and as I said, you can make it more advanced if you wish. And once that generates, I can then just display the results back on the map. Remember that it is a shapefile you get, so you can also display that shapefile within Esri. You can display the shapefile within Petrel. You can also load the shapefile into our prospects and leads database. So that's the portfolio management tool that we have that some of you may have heard about. So that tool allows you to store and manage all of your portfolio in a more sort of robust way than a lot of other tools on the market. And so you could take that shapefile, load it into the database, and then you would have identified some prospects where you could do further analysis. In this example, I'm simply going to display the shapefile. I'll give it a colour. Let's say colour it green for oil, give it a bit of translucency, click OK, and you'll see these are all the prospects that's identified in this area. Okay, final thing then, we've identified some prospects. Final thing I'm going to do is calculate some volumes for these prospects. Again, this can be done within the prospects and leads database, but I'm going to do it from within mapping to have a quick look, deterministic view of the volumes in place. I'm going to make my grid unpickable so that I don't click on it, and I'm going to look at this prospect here in the centre. Now, before I generate the prospect, I want to query some attributes just to get some more information out of my shapefiles. Remember that it is a real shapefile, it's not just an image here, so I can look at the attributes as well. And I'm going to look at the Z level, and I'm going to look at the name. So it's LCC22 and it's negative 1841. So I can now go ahead and calculate some volumes for this prospect. So I'll go into my surface modelling. I'm going to use the deterministic grid-based slices option, but also note that Petrosys PRO users now have access to the probabilistic resource calculator, which is the calculation part of the prospects and leads database that I spoke about earlier. So you can do Monte Carlo style volumetrics as well. I'm just going to simply look at a deterministic view here. And I'll click on my grid. I'm going to stick in a reference level, so remember that was at 1841, and I'll just call this my oil water contact. And there are various things I can do here, so I can increase the accuracy, I can change the types of units involved, I can include different polygons to delimit the volumetrics. So I'm going to go ahead and use the shapefile that's been generated from the LCC tool, and this is it here. And if you remember, I will select none of these, and I'm going to type in 22. That was the polygon name, LCC22, at negative 1841, so that's the one I'll use. Under reports, we can do things like get out a set of area depth pairs. If I want to use those for another software package, I'll just leave that off. And I'm going to just generate a web page style report as well. We can also include charts. We can have we can change the chart axis, and I'm going to just toggle on the very basic map display to make sure I'm calculating volumes in the correct area. So you can see from the very basic map view here, we're calculating volumes in the prospect that we thought, so we know we're working in the right area. And if I go to the tool here, we can see the report. It's given me a nice set of area depth pairs, it's given me my total volume, and it's given me in a set of slices at 10 metre intervals. Then I can go back and refine this, change this, but I now have some accurate volumetrics generated very quickly. So I'll go back to the PowerPoint. I'm just going to run through the steps again just to make sure I've covered them all. And then we can finish. So first of all, I showed how easy it was to display data, subsurface data, directly from your interpretation system. Showed you how easy it is to grid data, particularly using fault sticks, and showed you some of the other operations and algorithms available. Showed you the Spatial Editor and how we can edit surfaces and resync those changes back into the surface very easily. I should have also mentioned that when you save the grid within the editor, you can also just save it directly back to things like Petrel now as well. So when you've made those changes, if you want those changes available within your interpretation system, very easy to get those changes in there. We looked at the lowest closing contour tool, so how we can identify some prospects very easily. And finally, we calculated some deterministic volumetrics. But if you want to use the probabilistic resource calculator, you have that available as a Petrosys PRO user now. And you can do more resource management within the other tool called PLDB if you're interested in taking a look at that module. So thank you very much for listening to all that. I'm going to now stop the recording